Okay, so the neurotransmitters that we're going to be talking about in this section are called modulatory neurotransmitters. The ones that I'm going to be describing are actually all classical neurotransmitters as well, which means, of course, that they were identified early. They're going to include acetylcholine and the monoamines, dopamine and norepinephrine, which are catecholamines, and serotonin. And these have a modulatory kind of effect over our overall level of alertness and arousal. So there are other aspects of the term modulatory too, but what I want to focus on here is how when the dopaminergic, noradrenergic, we'll see that's norepinephrine, serotonergic and cholinergic systems are in, firing at reasonable rates, at sort of standardized kind of rates, you tend to be alert, engaged, aroused, like, able to deploy distributed networks that allow you to make decisions and, speak and understand language, perceive things, etc. When you get drowsy, when you start to drift down, in terms of your arousal level, well, those systems are firing, far less, rapidly, actually. And then when you get into what's called a slow wave sleep, like into really deep sleep, those modulatory systems are, to all intents and purposes, pretty much silenced. They're very quiet in terms of their firing rate. Interestingly, when you shift into what's known as Rem sleep, which is typically associated with dreaming, if you wake somebody up in that stage, they often report some sort of vivid dream. If you're recording EEG during that period, you'll often see the rapid eye movements going back and forth, but also activity from the cortex that looks a lot like activity you'd see in somebody who's awake and perceiving and engaged, in making decisions, etc. Interestingly, during Rem sleep, acetylcholine, we're going to see these are cholinergic projections, acetylcholine projections. We're going to see all these modulatory systems. They have nuclei sources in the brain stem. The brain stem cholinergic projection to the thalamus, which was a structure we'll talk about, sort of selectively pops back on and seems to wake up thalamocortical activity, and you get vivid sorts of experiences that are kind of associated with dreams. But in general, modulatory transmitters, these are active when you are alert, awake, engaged. When you're getting drowsy, their firing level is dropping. When you're in a deep, slow wave sleep, they're pretty much effectively off. And then when you go into REM sleep, acetylcholine selectively sort of pops back on.